Approximately 13.75 billion years ago, our universe as we know it today came into existence. Soon after, the primordial light began to permeate the cosmos and spread throughout the early universe. During this time, the universe itself was also expanding. However, the inflation of the universe slowed after its initial burst. But since then, the rate of expansion has been steadily increasing due to the influence of growing dark energy. Essentially, the cosmos is growing at an ever faster pace since its creation. Physicists and mathematicians have been studying the nature of the universe for centuries, attempting to unravel the mysteries it holds. Yet some scientists take an additional step into the unknown, contemplating what lies beyond our universe. Could there be something else beyond the existence of our universe? Other worlds within the universe that we can only speculate about, which very well might be the case. Here are 5 theories about what that something could be and the clues that support various theories. According to Hubble, the concept beyond the universe is quite complex because the universe first needs to be defined more precisely. A more accurate term that reflects the essence of the question is the observable universe, where the speed of light plays a crucial role since we can only see things when the light they emit or reflect reaches us. We can never see beyond the farthest distance that light can travel within the universe's existence. Cosmologists have calculated that the oldest photons we can observe have traveled a distance of 47 billion light years since the Big Bang. This means the observable universe is about 93 billion light years in diameter, give or take a few light years. These approximately 93 billion light years contain all the quarks, quasars, stars, planets, nebulae, black holes, and everything else ever recorded by a telescope, as well as everything we could potentially observe but haven't yet seen. However, the observable universe contains only the light that has reached us, meaning it is continually growing larger. Yet the universe is also finite, known as the Hubble volume. After the Hubble telescope, which gave us the most distant views of the universe to date, we can never see beyond this limit. Essentially, it is the only universe we can ever interact with. However, we know with near certainty that there is more universe beyond this boundary. Astronomers believe that the space invisible to us may also be infinite, with matter, energy, galaxies, and more distributed almost identically to the observable universe. Beyond the Hubble volume, we would not only find more planets, but also other planets very similar to our Earth. If we venture far enough, we might find another solar system with an Earth identical in every way, where you had cereal for breakfast this morning instead of eggs, and another world where you skipped breakfast, and yet another where you woke up and robbed a bank. In fact, cosmologists believe that if you travel far enough beyond the universe's boundaries, you will find another Hubble volume identical to ours. In these other Hubble volumes, there is another version of you somewhere that reflects every possible action you could take. While this may seem improbable, the infinity of the universe is indeed hard to grasp because it is simply beyond human imagination. To break this down according to the theory of relativity, objects close to each other cannot move faster than the speed of light. However, there is no such law for objects very far apart when the space between them expands. In short, it's not that objects are moving faster than the speed of light, but that the space between objects is expanding, causing them to move apart at incredible speeds. Ultimately, this means we could reach the edge of the observable universe only if we developed a method of transportation that allowed us to either move faster than the speed of light, a theory most physicists consider impossible, or to traverse beyond space-time using wormholes or warp drive, which most physicists also deem impossible. In 2008, astronomers discovered something very strange they hadn't anticipated: galactic clusters moving in one direction at an enormous speed of over 2 million miles per hour. New observations in 2010 confirmed this phenomenon, known as the dark flow. Scientists discovered this by studying some of the largest structures in the cosmos, giant galaxy clusters. These clusters consist of roughly 1,000 galaxies and very hot gas that emits X-rays. By observing the interaction of X-rays with the cosmic microwave background radiation, or the afterglow left by the Big Bang, scientists can study the movement of galaxy clusters. X-rays scatter photons in the background radiation and shift the temperature due to an effect known as the kinematic Sunyaev-Zel'dovich effect. This effect had not previously been observed as a result of galaxy clusters, but was first noticed by a research group led by Alexander Kashlinsky, an astrophysicist at NASA's Goddard Space Flight Center, when they studied about 700 clusters located up to 6 billion light-years away from us, halfway across the entire universe. They compared these clusters with a map of the background radiation obtained by NASA's Wilkinson Microwave Anisotropy Probe, WMAP, satellite. The movement of these clusters challenges all predictions about the distribution of mass in the universe following the Big Bang. One possible cause is massive structures beyond the Hubble volume exerting gravitational influence. Scientists are almost certain that the source of this pull lies beyond our known universe, implying that the structure of the infinite universe is not homogeneous beyond our viewpoint. These structures could be anything from clusters of matter and energy on almost unimaginable scales to exotic fractures that conduct gravitational forces from other universes. Talking about things beyond the Hubble volume can be misleading because it is still the same universe, just a different part of it. We cannot see the same physical laws and constants applying in another version of history. The expansion of the universe after the Big Bang led to the formation of bubbles in the structure of space. Each bubble stopped expanding with the rest of space and formed its own universe with its own laws and physical constants. In this scenario, space is infinite, and each bubble is also infinite because one infinity can contain an infinite number of infinities. Even if you somehow broke through the boundary of one bubble, the space between bubbles would still expand, so you would never reach the next bubble, no matter how fast you travel. The theory proposed by physicist Lee Smolin, known as the Fekan universes theory, asserts that each black hole in our universe causes the creation of a new universe. Each universe will have slightly different physical laws than the previous one. Thus, Smolin suggests a kind of natural selection for universes, as the laws and physical conditions that lead to frequent black hole formation also cause the creation of other universes, while universes that do not form black holes die out. The theory has since been refuted by Smolin himself and others. There is an endless number of parallel universes. While there are countless theories about parallel universes, the most well-founded theory today involves further developments in string theory ideas. This includes so-called membranes that vibrate in other directions. It would go beyond this video to delve into the details of string theory or membranes, but the essence of the theory is that the rippling of membranes beyond worlds in the 11th dimension are entirely different universes. When ripples collide, a new universe is formed. The effects of wave motion help explain the observed distribution of matter in our universe. One of the strangest elements of this theory is the idea that all the gravity we experience in our universe actually leaks into this universe from another universe in a different dimension, explaining why gravity here seems so weak compared to other fundamental forces. What do you think? Do other unknown worlds exist beyond our universe? Is there infinity, and if so, how infinite is it really? Parallel universes, the bending of matter, string theory, membranes, and black holes. Do you think it's all nonsense, or is there really something to it? Leave your thoughts in the comments.